All right, so this section is 5.3 binomial distribution. And once again, in the module for this section, I think it's module 10, I already have a video on binomial distribution. As soon as we're done here, I would go look at it and practice it on your calculator also. But we're also going to do that here. Binomial distribution, what we previously did was frequency distribution. What we previously just did, the previous section was called frequency distribution. This is called binomial distribution. And we know something's binomial, binomial by meaning two, if we have a fixed number of trials, n is the fixed number of trials, and you only have two outcomes, like true or false, yes or no. You could have 0.8 or 0.2. Do you see the probability of rain is 0.8 or probability of no rain is 0.2? You can only have two outcomes, two choices when you do binomial distribution. True or false, yes or no, 0.8 or 0.2. There's only two possibilities. Each trial is independent. That means it doesn't matter from previous trials. Like when you roll a dice and you get a 4, because you got a 4 the first time doesn't mean it's going to be anything different on the second roll. The second roll, you could still get 1, 2, 3, 4, 5, 6. It doesn't matter. The previous roll doesn't affect the next roll. And then we're going to have the probability of successes coming up also. So here, if they look, here's the probability of success. Here, if the probability of success is 0.8, then the probability of failure is 0.2. It has to add up to 0.1. And they show this P and Q. Once again, success, if success is 0.8, then 1 minus 0.8 is 0.2. Do you see? Then the failure is 0.2. N is the number of trials, and X is the number of successes. And we're going to use once again, we're using a calculator for this. And they have this drawn out formula. We're not going to do that. We're going to use our calculator. And here's the first question. And they even tell us, I think, how to do it on our calculator. Let's take a look here. A survey on a doctor's visit. A survey found that 1 out of 5 Americans say he or she has visited a doctor in a given month. 1 out of 5 visit doctor. If 10 people are selected, by the way, 10 is N, 10 is N. That's the number of trials. That's the number of people we're picking. Find the probability that exactly 2. So we want to find, exactly 3. Exactly means equals, that X equals 3. The number of successes equals 3. Exactly 3. The probability that exactly 3 visited a doctor. Can anybody tell me the actual probability that, what's the probability that somebody goes to the doctor? It's 1 out of 5. Do we know that in percentage form? 1 out of 5 is a probability that you go to the doctor. In percentage form, that's 0.20. So it's 20%. Do you see? You could write 0.20. You have a 20% of going to the doctor because it says 1 out of 5. 1 divided by 5 is 0.20. That's the probability of going to the doctor. So when we have equals, when we have exactly, when they say exactly or equals a number, sometimes they're going to say greater than, sometimes they're going to say less. When they say exactly or equals, we're using on our calculator something called Binomial Pdf. We're using Binomial Pdf. And once again, if we look at here, it even tells us what to click. Second vars, option A, Binomial Pdf. N is the number of trials. We have 10 people selected for this. P is the probability of a success. A success is that you go to a doctor and it said 1 out of 5 go to the doctor. So P is 20%, 0.20. And X is how many, what's the success? Exactly 3. You just see that's the X part, exactly 3. So on our calculator, let's type in second vars. How do I get to there? Let me erase all this other stuff on my calculator. Does everybody see second vars on your calculator? Let me put it back on my calculator. Second vars is going to distribution. I'm trying to get there. There we go. So second, and then vars is right here. VARS, second vars. And we're doing Binomial Pdf. Do you see that's number, Binomial Pdf? Oh, that brings up a good point. Binomial Pdf is A. There's also a Binomial CDF, which we're going to use later on. So you have to scroll down. When you hit second vars, you have to scroll down to A, Binomial Pdf. Hit enter. Let me make this bigger so I can see what I'm doing here. The number of trials, there are 10 people doing this trial. The probability of a success, we said, was 1 out of 5. You can put 1 divided by 5, or you can put 0.20. And we want to know exactly 3. So Binomial Pdf is exactly 3. When I hit enter and enter, oh, I typed in the wrong, I'm not supposed to have that. Second vars, go down to number A, Binomial Pdf, 10.23, and hit enter one more time, and it gives us the probability. When we do these probabilities, we always take the Binomial PDFs to 4 decimal places. So the probability that we have here, the answer will be 0.20132. We take it to 4 decimal places, 0.2013. So Binomial Pdf is A, second vars A. Second vars option A. And PDF is where it says exactly equals. And you should get that as your answer. I got a rock holding that up. All right, let's try the next one. Find the probability that at least, okay, I'm not going to do this next one yet. It's a little harder. I'm going to go down. I'm going to make up my own, okay? I'm going to make up my own. I want you to see. So we're going to do this one, but I'm going to change it. Same one, 1 out of 5. This probability is 0.20. If 10 people's in a survey, that's n. Find out the probability that less than 3 have a doctor's visit. So we're not doing exactly 3. Remember, equals was Binomial Pdf. We're doing x is less than 3. I don't think, is that what this one's not less than 3, right? I'm gonna do. I'm gonna change it a little bit. Hang on, because I wanted to look at that. Give me a second. I'm still gonna change it a little bit. I'm gonna do less than or equal to. And the video that I did already, that's there, is gonna explain every procedure. We're gonna do equals. We're gonna do less than. We're gonna do less than or equal. We're gonna do greater than. We're gonna do greater than or equal. So there are like 5 different possibilities of typing this in your calculator, and each one is typed in differently. Where x is less than or equal to 3. In order to do this problem, we're going to do the same thing. Second, by the way, less than or equal to 3. Let me show you what this means. A lot of people don't understand what this means. It says find the probability that less than or equal to 3 will have a doctor's visit. In other words, 0 people, anything less than or equal to 3. 0 people can have a doctor's visit. 1 person can have, 2 people can have, or 3 people. Less than or equal to 3. Then you could have 4, 5, 6, 7, 8, 9, or 10 people because there's 10 altogether. We want these less than or equal to 3. Do you see? We want to do all these 3 and we want to add them up. 0, 1, 2, 3. Our calculator will add all 3 of these up, less than or equal to 3. Our calculator will add them up. If you go to second vars, and go to B, and less than or equal to is binomial CDF. So we have to go to second vars B, binomial CDF, and hit enter. The number of trials is 10. The probability is 0.2. The x value is 3. Even we're going to do less than or equal to 3, but we're going to type in 3 because when you say binomial, when you say part B, they know it's less than or equal to. So there's what I typed into my calculator. Trials is 10, probability is 0.2, value is 3. And once again, I hit second vars and I went to B, binomial CDF. CDF means less than or equal to. Hit enter. All those are in. Hit enter and hit enter one more time. And there's our answer, 0.8791. We take it to 4 decimal places. Our answer here is 0.8791. So I changed the problem and it's 0.8791. Okay. That's less than or equal to 3. So I'm going to change the problem again. There's 5 different scenarios here. There's 5 different scenarios. And I show you all 5 of those in that other video. So I'm going to do probably a couple of more. So we're going to do less than 3 this time. Last time we did less than or equal to 3. This time we're just doing less than 3. Now, if I have 10 people, 0 people could go to the doctor. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 people can go to the doctor. When I say less than 3, which ones are less than 3? Which of these numbers are less than 3? You guys are sleeping, aren't you? 0, 1, and 2. These are the ones that are less than 3. See, the last problem we had less than or equal to, so we included 3. But this one doesn't say equals to. It doesn't say less than or equal. It just says less than. So the numbers that are less than 3 are 0, 1, and 2. And we're going to do a binomial CDF also. But remember, binomial CDF only does less than or equal to. Binomial CDF only does less than or equal to. So what number do I have to put in for binomial CDF? What number do I have to put in here? We can't do less than into binomial CDF. It has to be less than or equal to. Do you see how binomial CDF for this problem, less than 3, I have to put a 2 in here because less than or equal to 2. Even though the question asks less than 3, that's true, but the numbers that are less than 3 are 2, 1, and 0. Another way of saying x is less than or 3 is x is less than or equal to 2. These are the same thing, right? Less than 3, these numbers are less than 3. They're also less than or equal to 2. So we're going to do this, when we do less than 3, we're going to do binomial CDF, x is less than or equal to 2. So once again, second vars, go all the way down to B. And everything gets typed in except number of trials is 10. And everything's going to be the same except when we say less than 3, we have to put a 2 in there because it's going to be 2, 1, and 0. Less than 3 is the same thing as saying x is less than or equal to 2. I hope that makes sense. The other video they do, I think, explains the same thing. I do it the same way, pretty much. And when I hit enter here and enter here and enter one more time, I get 0.67779, which is 0.6778. This probability is 0.6778, rounded to 4 decimal places. All probabilities for binomial distribution go to 4 decimal places. All right, so now I'm going to do one more. The next one that's actually on the list. It's a hard one. That's why I had to show all this first. It's not a hard one. If you do it the way I do it here, I think we can get through it. So it says a survey of teenage blank, blank, blank found 30% of teenagers consumes, I guess I should bring, research unlimited, 30% of teenagers consumers receive their spending money from part-time jobs. So the probability is 30% that they get their from a part-time job. That's the probability, 30% get it from a part-time job. If we have 5 teenagers, n equals 5, there are 5 people we're going to randomly select. Find the probability that at least three will have a part-time job. So let me put all the numbers here. N is 5. So we could have 0, we could have 1, we could have 2, we can have 3, we can have 4, and we can have 5. You can't have more than 5. You can only have 5. People have a part-time job, 4, 3, 2, 1, or 0, right? We're asking 5 people. You can't have 6 people because you have 5 teenagers and you're asking them, do you have a part-time job? 5 could say yes, 4 could say yes, 3, 2, 1, or no, 0 could say yes. Okay, so, but the hard part here is trying to figure out at least 3. What does at least 3 mean? Which of these numbers are at least 3? Which ones do I circle for at least 3?
0, 1, 2, 3.
Well, that's why this is a hard one. At least 3 means is the least. We're picking these 3 numbers. Do you see? At least 3 of them. So you could have 3, you could have 4, or you could have 5. Okay? So at least 3 means 3 is the least. 3, 4, and 5. Now, we only have 2 things on our calculator. Our calculator only does 2 things. It does Binomial Pdf, but that's when x equals a number. Or it does Binomial CDF. That's when x is less than or equal. Our calculator will only do these 2. So this is the hard part, and they even tell us how to do it down here. So you have to understand all of these, remember, all of these probabilities, if I added up all those probabilities, the probability adds up to 1. I need at least 3. I need, another way of saying this is x is greater than or is greater than or equal to 3, right? 3, 4, or 5. Our calculator won't do greater than. Our calculator will only do less than or equal to. So we're going to do these. We're going to do these. X is less than or equal to 2. And we're going to subtract 1 minus that. The whole thing minus this equals this. So do you see? We're doing 1 minus second vars option of instead of 3, we're picking 2. 3 minus 1 is 2. X is less than 2. So we're going to do 1 minus this one. So on our calculator, Lord help us, we're going to type in 1 minus second vars, just like here, option B. So on our calculator, 1 minus second vars. I should actually show you while I'm typing this in if I can. Where is that bright light coming from? 1 minus second vars and go to option B. We have n is 5. Our probability here was 0.3. and our x value is 2. We're doing x is less than or equal to 2, but we already did 1 minus. When I hit enter and hit enter, do you see it's doing 1 minus the binomial of, it's doing 1 minus the binomial of that, and we get an answer of 0.163, and if I round it to 0.08, 0.1631. This is the actual probability. That's the answer. So at least 3 means 1 minus the probability of 2, because your calculator cannot do greater than 3. Your calculator can only do equals or less than or equal to. So we do the whole thing, 1 minus this, that'll tell us what this part equals, and that's what we're looking for. So once again, go to that video that I have in Module 10, watch that video, practice it on your calculator, and understand each of those. I think I go through 5 different scenarios. And here are the scenarios, by the way, and they tell you how to type it in. Once again, exactly. When we say exactly, it's PDF. That's the equals. When we say less than, we're not going to do less than. We're going to less than. Where's less than or equal? Oh, right here. Less than or equal to, another way of saying that is at most. If I had 0, 1, 2, 3, 4, 5, at most 3, that 3 is the most. Do you see? That would be x is less than or equal to 3. At most 3 means less than or equal to that number. They're showing that here. Fewer than, when we do, if we do fewer than 3, 0, 1, 2, 3, 4, 5, fewer than 3 really means 2, or, you know, there's no equal sign for 3. If we say fewer than 3, we have to pick 0, 1, 2. Do you see fewer than 3? You put a 3 over here. 3 minus 2, you have to type in NP2. Fewer than 3 is a 2 because there's no equal sign. At least, it's going to be what we just did, 1 minus second vars with 1 less than the number that we at least did. And then the probability of more than a number is 1 minus the binomial CDF. You know, if we did 0, 1, 2, 3, 4, 5, if we do more than 3 are these two numbers. You got to do 1 minus these 3. 1 minus, then x is less than or equal to 3. All right, so once again, practice those. I have those in a video in the module already. It's really good practice. All right, so then they tell you how to use the table. I'm not too worried about using the table. Even if the homework says use the table, don't use the table, use your calculator. Okay, so binomial distribution, and this is on a test, and a lot of people mess this up. Binomial distribution has their own formulas for mean, variance, and standard deviation. Binomial distribution has their own formulas. The mean stands for n times p. Remember, n is the number of trials. P is the probability. N is the number of trials that we're doing, how many people we're surveying. Variance is n, the number of trials. P is the probability. And remember, Q is 1 minus the probability. So if the probability is 0.8, then Q is 1 minus 0.8 or 0.2. So P and Q, when you add them up, should equal 1.0. And standard deviation is the square root of NPQ. All right, so we need to know those. Let's try a problem with those. The statistical bulletin published, blah, 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 report 2% of American births are twins. So the probability that you get a twin is 2%. Another way of writing that is 0.02. That's 2%. In a random sample of 8,000 births, n equals 8,000. We're surveying, or we're looking at 8,000 births. We need to find the mean, the variance, and standard deviation. The mean is n times p. N is 8,000. P was 2%, or 0.02. And we just put that in our calculator. 8,000 times 0.02. And our mean is 160. Our variance, what's the formula for variance again? Was NPQ. That looks like a G. Our N is 8,000. Our P was 0.02. Can somebody tell me what our Q looks like? What is our Q?
160.
60? No.
160.
No. Anybody else? It's 0.98. Remember, N if N is 0.8, then Q is 1 minus 0.8, or 0.2. So if I'm sorry, if P is 0.8, then Q is 1 minus that. They have to add up to 1. Do you see 0.02 and 0.98 add up to 1? P is the probability, Q is the opposite of that probability. I want to take you back up here. I thought we talked about that up here somewhere. Yeah, I'm sure we did. I thought we did. Yeah, we did somewhere. I don't know. I think it was at the right there. Q is a failure. So you see, if P is 0.02, then 1 minus 0.02 is 0.98. That's what Q equals. So do you see P and Q add up to 100%, or 1? All right, so variance is 8,000 times 0.02 times 0.98. 8,000 times 0.02 times 0.98. And I get 156.8. That's the variance. And finally, standard deviation is the square root of NPQ. The square root of 8,000 times 0.02 times 0.98. So put all that in the square root. Square root of 8,000 times 0.02 times 0.98. And everything has to be kept inside the square root. And when I hit enter, I get 12 point, I'm going to go to one decimal place, 12.5. And that is whatever section we just covered. What was it? 5.3. Once again, watch that extra video I have in the module. It gives you practice doing the binomial distribution. Let me hit stop.